Okay, we're moving on to question 2. Okay. So question 2, in this case, and generally in most papers, focuses on the maths of finance, right? So when you hear the word maths of finance, the first and foremost thing you should be thinking of is interest, right? 2 types of interest, simple and compound, okay? Simple interest, you earn the same amount of interest in every period, right? Whereas with compound interest, you earn interest on interest. Very important differentiator. Okay. Also with compounding, right, it's very important how regularly we compound. The more regularly we compound, the better if you're earning interest. The more regularly we compound if you're paying interest, you're not having a good time, as it were. Okay, so let's just jump into the question and see what it is asking us. So it says, Boosie opens a new credit card account that charges compound interest of 12.3% per annum compounded weekly, right? So how many weeks are there in a year? 52. You should be writing this as you go through, right? Because what I'm showing you is that no piece of information they give you is sort of peripheral. It's very important to see what they're giving you because you have to use it in answering, okay? So we have a nice little credit card from from the post office, okay, right? And then the note says, for the calculations in this question, assume the relevant year has 52 weeks. Okay, so I wrote it over there. They gave it to us over here. They're basically doing that because sometimes you have leap years and, you know, there's sort of fractional weeks in certain years, but they've been quite explicit here, okay? It says, she purchases a computer for an amount of $12,349 immediately after activating her credit card. Okay, so she's effectively taken out a loan in essence, right? Using her credit card, and she's going to have to pay that back. Otherwise, she's going to be charged interest, right? So if she pays it back within the credit card period, she's not charged interest. That's the whole reason why a lot of people have a credit card. But if she doesn't pay it off within that first time period, she's going to start being charged interest, okay? So let's see what they're asking us. It says, show the balance owing on the credit card 1 week, right? After the purchase will be, we have to show that it's this amount, okay? So what's important about that, right, is we see that it's more than the initial amount that she took out to buy this laptop, right, which we would expect because she is paying interest, okay? So we know that it's compound, so we're going to be thinking of using this formula. Okay, now you could be saying, Margs, I don't know that formula. It's on your formula sheet. I don't have the formula sheet with me right now. Actually, I do. I'm lying. Oh, sorry about that. I'm back. Okay, let's just see where it is in the formula sheet. You see, there it is over here. So this is simple interest, simple depreciation, compound interest, compound depreciation. Okay, so you do have this, so you don't have to remember it off the bat. Not that it's not a very complicated formula, but you might just not have it off the top of your head. Okay, so there it is. So let's figure out what all these different things are, all the different symbols. So P is going to be the amount that she took out, right? For it's a loan she took out, basically, the principal amount to buy the laptop. What is the interest? Now, this is an interesting one, right? Pardon the pun. Is that, so you know that it's this much, right? So I'm just writing the percentage as a decimal, right? So I've literally said 12.3%, and then I've just divided it by 100 to write it as a decimal, okay? Right? But we have to always divide it, right, by how often it's compounded, right, within a year. And we know that that is 52, right? But it only wants the amount after 1 week. So N is just going to be 1. So you actually don't need to put it there because it doesn't make any difference to the sum if you put it or you don't. But let's now put this into our calculator. Okay, so 1, 2, 3, 4, 9. Was that right? Right, open brackets. 1 plus 0.123 over 52. Okay, you can put it in like that. You don't have to put it to the power of 1 because if you have a bracket like this, it's the same as saying to the power of 1, right? It'll be exactly the same. If you don't believe me, just quickly type in the 2 alternatives and you'll see that it will give you the same answer. So look, we have actually got exactly what they said we should. Okay, remember with currency, we always round off to 2 decimal places, round it off to 2 decimal places, 3 marks in the bag. Okay, the important thing here is your interest rate. Okay, must understand this. Okay, it's all about how often it is compounded. It's compounded 52 times in a year because there are 52 weeks in a year. Okay, so that's that question. Let's now move on. Okay, so now it says, Okay, it says determine how long, let me check you can see what I'm saying. Determine how long it will take Boozy to pay off the money that she owes on her credit card if she repays 94 Rand and 75 cents per week and she does not make any other purchases using the credit card. That's very important, right? Because if she makes more purchases on the credit card, it means that she's going to go into more and more debt, right? Which means that she's going to have to pay it off over a longer period of time. So it's saying she got this credit card, she bought this laptop, and now she's paying it off. Okay, but she's paying it off regularly, right? And when you see that she's doing something per week or she's doing something regularly, you should be always thinking annuity, okay? And what does annuity mean? It means regular cash flows, right? And that's what they've given us here, regular cash flows. Okay, so let's see which one of these we think would be a good fit for the question. So these are our two annuity formulas, right? This is future value and this is present value, right? So this one is saying, what is the value of money now? This is saying, what is the value of money in the future at a specific time in the future? So let's just read the question again. It says, determine how long it will take Boozy to pay off the money that she owes on her credit card if she repays this much per week and does not make any other purchases. Now, we know how much she took out right now. That's how much she took out. That was the loan she took out now, right? And we know how much she pays off. So I would use the present value formula, right? Because we know how much she took out now. We don't know how much she's going to pay back, right, in the future. We don't know that. We'll have to calculate that. But we don't know that right now. So let's use the present value formula. Okay, and let me just write that out for you. I'm just copying this from the formula sheet. So just to remind you that I'm not just pulling this like out of my head, right? That's a present value formula. So now let's sub in some of the values we know. So we know 94.75 is X, right? X in this case is the regular payment. So it'd be that 94.75. Okay. Then what is the interest? We talked about this in the previous question. 0.123 over 52 to the power of negative n. Now you'll be saying, Marks, why haven't you populated n? But n is what we're trying to solve, right? It says, how long will it take her? That is what we're trying to solve. We're trying to solve for n, right? So we're not going to populate n because we don't know what that is, okay? How much is the loan that she takes out? It's this much, right? So do you see what we've done is I've basically said, what is the best formula to use? Okay, subbed in all the stuff. I mean, also, I mustn't say words like that. Subbed in all the values, not just the stuff. Subbed in the values, right? And now we can solve for n. Now you could be saying, but n is in the exponent. How do I do that? Wada. Well, when we see a variable in the exponent, we should always be thinking about our good old friend log. Okay, log helps us, and the log rules help us to get an exponent down to a base. Okay, and I'll show you how to do that now. So what I'm going to do is I'm going to do a little bit of algebraic manipulation. Okay, and don't be super phased by that. Not a problem. Okay, so I'm just going to write out what we're going to do. So I'm going to say, I think I might be a bit pressed for space here. Let me just write that equal sign here so I'm not too pressed. So we're going to divide both sides by this 9475. Okay, so I'm going to say 12349. I just want to check I wrote that correctly. 12349, that's correct. Okay, then we're going to divide it by 94.75 because remember we basically are just doing algebra now. Okay, I'm undoing, and remember in algebra what we do to get a value by itself, we use BODMAS, but we undo BODMAS, right? So we almost do BODMAS in the opposite direction. So BODMAS is like this, right? BODMAS is like that, and generally we're told, you do brackets, then you do division, multiplication, addition, and subtraction. When you're doing algebra, you're undoing that, right? You do addition and subtraction first, right? If it's outside, so let's say there was like a +2 here, you would then first take that away. Then you do multiplication and division, and then you do brackets, right? You do it in the opposite direction. Very important with algebra. You're undoing BODMAS. Okay, cool. So I've now divided it by that, so that's now cancelled on that side, and I'm going to multiply it by, okay, let me just show you the steps. I'm just scared I'm going to run out of space here, but it matters not. We can just crunchy stuff in. Okay, then I'm going to times it by 0.123 over 52, right? I'm getting rid of all these things, okay? And then I'm going to minus, so I'm just going to minus 1. Sure, it's a bit ugly there, Marks. Okay, so then this is what we're left with on that side. Okay, Sorry, my dog seems to be making the most amount of noise in the background. I don't know what's up. Okay, so I know this is a bit crunchy, right? But you can just pop it into your calculator, so worry not. Okay, but remember, we undoing BODMAS to get the variable by itself. But when we're on a side and we're trying to solve a side, we still apply BODMAS, right? So I did the brackets first, right? So I did that. I put that into my calculator. I'm now putting this into my calculator. Wunderbar. Okay, we get that. We subtract 1. Okay, so that's what this side equals. Okay, and that side, we can't reduce it yet because we have this n in the exponent. So now we have two sides, right, with negatives. Okay, importantly here, guys, don't round off yet. Only round off at the end, okay? Because sometimes when you round off prematurely, right, you can then get an incorrect answer at the end because you basically are filtering that value throughout your whole equation, and you don't want to do that yet, only at the end, okay? So now we have two negatives. We can just hoy those away, right, because they cancel each other, right? But now what we're going to do is we're going to log both sides, okay? So I'm going to log that value. So I'm not going to write it all out. I'm just going to solve that, keep that in my calculator. And we're going to log this side, okay? And note what I'm doing there, guys. Do you see that because of log rules, right, the negative n can come to the front, okay? The exponent can come to the front. If you're like, Margie, what witchcraft is this that you're doing? Please go and revise your log rules, okay? This is not a difficult thing. This is actually one of the most practical applications of log, right? So just go and check those rules. So now it's easy, right? I can just say negative n equals log 0.69 ... over log 1 plus 0.123. Like that. I don't know, I drew such a long line. Okay, and that will give me the value of n. So, remember this, we took away the negative there. Important, right? So I'm going to say, without losing all the decimal places, you can use your answer there, right? That little answer button to keep all the decimal places, over log, what is it? 1 plus 0.123. I hope I could put this all in correctly. Sometimes I'm very bad with my inputting of numbers. Okie dokes. So, I'm going to write it over here, guys. Excuse my very tardy use of space. So, negative n equals negative 156. Let me check you can see. 0.008034. Okay? So, what we need to do is let's divide both sides by negative. Take that away. And let's do it in years. Did they say how long it takes? So technically you could just say n equals 156 weeks, right? Because they didn't specify whether they wanted in years or months or anything like that. But let's just, so I basically took away the negative, and I'm going to divide by 52, right? Because there are 52 weeks in a year, okay? And it's 3 years. So n equals 3 years. Okay, and remember, you can round off at the end. Okay, so, I mean, there was a lot of work involved there, but I also was very explicit about the steps that I did. You don't necessarily have to be that explicit. I just wanted you to follow me. Okay, so that's that. You always get a question like this. You always, not always, I can't say that. I don't take the exam, I don't know. But it's very frequent that you see questions like this because they're wanting you to demonstrate that, one, you understand annuities, but two, you understand that maths integrates across topics, right? Log can be used in finance. Okay, that's important. Cool. Let's now go on to the next question. Okay, it says, if the depreciation rate of her computer, right? So depreciation, you should be thinking, okay, no problemo. We're either going to be using this. We're going to be using one of the negatives, right? Because this indicates depreciation, right? Depreciation is the opposite of appreciation, right? It means that it loses value. Whereas with interest, it gains value. Okay, it's important. If the depreciation rate of her computer is 20% per annum on a straight line basis, okay, important. When you see the straight line basis, you should be saying, thank you very much. You just told me it is simple interest. It's important to understand the words used, okay? Determine what its value will be after 2 years. No problemo, right? We know here we're working with simple interest. We're going to be working with simple depreciation. So again, sorry, I must be very explicit. It's not simple interest. It's actually simple depreciation, okay? Must make sure that my explanations are consistent here, because it's losing value. Not a problem, okay? So what we do here, right, is we're wanting to work out P because they're saying, what is its value after 2 years? So saying, what is this value, the principal value, right? How much is that? Actually, no, I'm lying. Sorry, the accumulated value. In this case, right, it's not really accumulated. It's going to be less. So we know our principal value was this. That's how much she paid for the laptop, right? We know that. But now we want to say, okay, well, the laptop loses its value, okay? It loses its value every year, okay? So 2 years, because it said 2 years over here, and 20%. This 20% you can write like 0.2, or you can write 2 over 10, or 1 over 5, whatever, as long as it represents 20% and you put it into your calculator correctly. So it's depreciating. We know that because of the negative. It's been given to us. We sub in all our values, and we find the accumulated amount. Now, in this case, accumulated does not mean bigger. Often when we taught finance, the accumulated amount, we always like, well, a check you can do is that your accumulated amount should always be more than your principal. When it is depreciating, the check is opposite. The accumulated amount, right, or the new amount, I don't want to call it accumulated because accumulated implies that it's more, right? But the amount that it is, this A value, is going to be less than the principal value, right? Because you're losing value, right? Anyone who does accounting or economics or business should understand, or at least be sort of fairly familiar with this concept of depreciation. Okay, cool. So we'll just put this into our calculator. You see, you can put this 20% in many different ways, right? And I want you to be comfortable with that. Okay, so we know that after 2 years, right, this laptop is only worth 7,409 Rand and 40 cents. Remember, always 2 decimal places. Because it's depreciated, it's less than the amount we purchased it for, right? And we know that a lot of assets are depreciating, right? Like cars, unless you buy like a vintage car or something like that. But in general, cars depreciate, laptops depreciate. So it's not something that is uncommon. It's something that is very common in the world of finance. Okay, that's 3 marks. Relatively quick, right? Let's now go to our last finance question, and this one is 6 marks. Okay, so the trick is not to panic up in here, right? We just need to read what's going on. Okie doke. So it says she wants to sell the computer after 2 years. Okay, will the depreciated value of the computer be sufficient to pay off the outstanding balance immediately after the 100th and 4th payment show all working? Okay, now this is quite important. Okay, we're saying, okay, how much has she paid off? Okay, how much has she paid off, right, after 2 years? Okay, and if she has paid off if she has paid off this amount, right, is the rest that she has to pay off, could it be settled by her selling the computer? Okay, so let me show you what that means. So what we want to do, right, is what we fundamentally want to calculate is the outstanding balance. Okay, now the outstanding balance, oh goodness, sorry, let me make sure you can see what I'm doing. The outstanding balance is actually what is the accumulated amount at time 2, right? So what is the interest that has been accumulated up until time 2 on the credit card minus the amount she has paid off, right, by time 2, okay? Because that's how much she has left, right? Because we're saying, well, she took out this loan of 12,349. It earns interest, right, over these 2 years. But every week she's paying back a little bit more, okay? So it's going to start reducing, right? But there's still interest that is accumulating. So interest is accumulating because she's taken out this loan, but she's paying it off every week, right? So we want to figure out how much she still has outstanding. Okay, so let's figure this out. Okay, so let's say how much interest is going to be charged by time 2, right? At time 2, how much interest is going to be charged on her loan? So actually, let me just write out the formula before I just start putting in numbers. I'm just going to put this equal sign here. I generally like putting equal signs underneath each other, but this is going to be quite a long equation, and I don't want to go over lots of lines. So we know that the accumulated amount, right, after 2 years, it's going to be this, because it's purely saying the principal amount you put in with the interest that's being charged. Then we're going to subtract, right? We're going to subtract the future value, annuity formula, right, at time 2, okay? We're going to subtract this future value at time 2, because now we're looking at a time in the future, right? We're not looking right now, like the present value. We're looking at a time in the future, okay? So let's just write out those 2 formulas to help us bear in mind what we're doing, okay? So I'm going to say P1 plus I to N, okay? So I'm not going to write the A in this instance because we're not working out A. We're working out the outstanding balance. So we're actually working out A minus F, okay? Because we're saying how much interest is being charged up until now minus how much is being paid off, right? Or subtract how much is being paid off, okay? So we have that's how much is being accumulated minus how much is being paid off, okay? Importantly here, guys, always write your formula correctly. If you don't write your formula correctly, you are headed for disaster. Okay, cool. So what was the principal amount? Well, that was how much the loan was. What is the interest? Well, we know that it is this, right? After 2 years, right? Now, we have to say 2 times 52 because, remember, we are working with a weekly interest rate. And whatever's up here must be consistent with the compound, whatever's up here. The exponent that is associated with the bracket must be consistent, right, with the compounding period inside the bracket. If it's monthly in here, it must be monthly there. If it's weekly there, it must be weekly there. We know it's weekly here, therefore it's weekly out there. Okay, very important to be consistent. Okay, then we're going to subtract or minus, same thing, right? So the installment, she pays every month. It wasn't every month, I think it was every week, right? Every week. Okay, then again, we sub in all our values, right? 52, and then we say 2 times 52, right? Again, what's in the bracket must be consistent with the exponent. Okay, sorry, my writing's so ugly today. Okay, and then we again put our interest at the bottom. Okay, so now all we need to do is solve. Okay, so it's quite a long one to put into our calculator. I think we might need to do this term first and then that term, but that's not a problem. Did I do that right? Yes, I did. Okay, most important thing, I know I'm saying this, I'm sounding like a broken record over here, but we need to make sure we type in things correctly. Biggest error that, or not biggest necessarily, but one you don't want to be doing because it's a silly one. Okay, remember, don't round off. We only round off at the end. Done the first term. Let's put in the second term. Okay, hopefully I type this in correctly. Okay, to the power of 52 times 2 minus 1, close bracket, over 0.123 over 52. I think I did that correctly. Okay, 11,156.97628. Okay, so this is how much is owed at time 2. This is how much has been paid off at time 2. So the difference between them is what is outstanding. Okay, so now we're going to say 15788.54384. Subtract the answer. Subtract the answer for the previous calculation we did there for this term. Okay, and it gives us 4,631.57. Importantly, okay, round off to 2 decimal places. We are talking about a currency. Okay, and we know that this is less than the amount that we calculated, the depreciated amount, right, at the end of 2 years, which is 7,409.40. So it'll be less than that, right? So if she sells her laptop at this point in time and she gets this price, right, it will be enough, okay? So what it asked, it said, will it be sufficient? So we say, yes, it will be sufficient. You can say enough. You can say Okay, no, I wouldn't just say anything, but say sufficient or enough or yes, that would be correct, right? Because part of you will actually get a mark for saying this, right? Because this is answering the question. Doing the calculation isn't answering the question, right? The calculation enables the answer, but the calculation is not the answer, okay? So that's how we do that. What we're saying is how much was owed at time 2, how much had been paid off by time 2, how much was left. If she sells the laptop, this is how much she can make, right? Well, she's actually going to make a profit, right? Because she'll cancel her debt and then she'll make a profit of like just under 3,000 Rand, okay? So it's important to understand these dynamics, okay? I hope that was helpful. Financial maths is just one of those ones you have to practice often because they often give some tricky scenarios, but I hope that was helpful. And let's now move on to question 3 and some derivatives.